Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about Part 3, Design of Reinforced Concrete, Question and Answer. 1. How the load is distributed when flights or landings are embedded into walls. Where flights or landings are embedded into walls for a length not less than 110 mm and designed to span in the direction of the flight, a 150 mm strip may be deducted from the loaded area and effective breadth of the section increased to 75 mm for the purpose of design. 2. Define depth of section. The depth of section shall be taken as the minimum thickness perpendicular to the soffit of the staircase. 3. What are the loads acting on staircases? Explain. Dead loads. Self-weight of stair slab, which includes the waste slab, tread rise, etc. Self-weight of finishes, 0.5 to 1 kN/m2. Live loads is 875 parts. 2. Specifies the load to be considered as UDL of intensity 5 kN/m. 2. FOR public buildings and 3 kN/m. 2. FOR residential building where the specified floor do not exceed 2 kN/m. 2. The staircases are should not liable for overcrowding. 4. Explain structural behaviors of staircases. Staircases can be grouped depending upon the support conditions and the direction of major bending of the slab component under the following categories. Staircase slab spanning horizontally, along the slope line. Staircase slab spanning transversely, slab widthwise with central or side supports. 5. What is masonry? Masonry is a structure built of an individual blocks of materials such as stone, brick, concrete, hollow blocks, etc. bonded together with some form of mortar such as lime mortar, cement mortar. 6. What is the size of bricks? Without mortar joints. Size of standard brick equals 190 mm times 90 mm times 90 mm. Size of modular type brick equals 190 mm times 90 mm times 40 mm with mortar joints. Size of brick equals 200 mm times 100 mm times 100 mm. Size of modular type brick equals 200 mm times 100 mm times 50 mm. 7. List the types of bricks. 8. Define mortar. Mortar is a combined material formed with intimately mixing bonding material like lime or cement, with a fine aggregate like sand in certain proportion and with adequate quantity of water. Common clay bricks. Class I bricks. Class II bricks. Class III bricks. Heavy-duty bricks. Class I bricks, or A-class bricks. Class II bricks, or B-class bricks. 9. What is the classification of walls? Define criteria. Design criterion is that the actual stress produced due to loads in the structure should be within permissible limits. Load-bearing walls. Cavity wall. Faced wall. Solid wall. Solid wall with piers, pilaster. Veneered wall. Non-load-bearing walls. Curtain wall. Freestanding wall. Panel wall. Partition wall. What are the factors of permissible stress, or allowable compressive stress? Cross-sectional area of the masonry. Eccentricity of loading. Shape and size of bricks. Slenderness ratio. Strength of mortar. Type and strength of bricks. What is meant by slenderness ratio of a masonry wall? It is the ratio of effective height to effective thickness. Equals H slash H. What is the purpose of providing a lateral support into a masonry structure? Masonry structures gain stability from support offered by cross walls, floors, and roofs. Lateral supports for load-bearing walls or columns limit the slenderness of the structure. Further, the lateral support reduces the possibility of buckling of member due to vertical loads and to resist horizontal forces. What is a pilaster in bricks masonry wall? Solid walls are thickened at intervals by increasing the cross-section. The thickened portions are called as piers or pilasters. They are used for one of the following purposes: to carry concentrated loads from roof or floor beams, to provide lateral support, to reduce the slenderness ratio by stiffening the walls. What is an equivalent eccentricity? In an eccentricity-loaded wall, there is an axial load and a bending moment. These two may be combined into single resultant load acting at a distance. This is known as equivalent eccentricity. List the factors which contribute for eccentricity on bricks walls. Geometry of the support. Long floor edges. Magnitude of loads. Relative stiffness of slab or beam in the wall. Unequal spans. How do you determine the average effective thickness of wall with opening? Equals dash times H equals dash, where L equals length between outer wall faces, A equals width of spacing, T equals thickness of wall. Define retaining walls. Retaining walls are structures used to provide stability of earth masses. Other loose materials. That is, when field conditions do not allow the earth pressure to assume its natural shape, or when abrupt changes in the ground surface elevation are needed. Retaining walls are used. Where are used the retaining walls? Basement wall, box culvert, depressed roads, Elevated protection. Erosion protection. Flood wall. For underground water tanks. Landscaping. Retaining a railroad or highway in hilly area. Used at the ends of bridges in the form of abutments. Types of retaining walls. Buttressed wall. A buttressed wall is a modification of the counterfort retaining wall in which the counterforts, called the buttresses, are provided to the other side of the backfill. However, the buttresses reduce the clearance in front of the wall, and therefore these walls are not commonly used. Cantilever retaining wall. A taller wall with extended toe and heel to offset the large lateral pressure tends to overturn the wall. A cantilever wall has part of the base extending underneath the backfill, and the weight of the soil above this part of the base helps prevent overturning. T-shaped. L-shaped. Counterfort retaining wall. The vertical stem and the heel slab are strengthened by providing counterforts at some suitable intervals. Because of provision of counterforts, the vertical stem as well as the heel slab acts as continuous slab, in contrast to the cantilevers of cantilever retaining wall. The toe slab, however, acts as cantilever bending upwards. This type of retaining wall is used when backfill of greater height is to be retained. Gravity retaining wall. A gravity retaining wall is the one which resists the lateral earth pressure by its weight, in contrast to the cantilever and counterfort retaining walls in which the pressure is resisted by bending action. A gravity retaining wall is therefore thicker in section. They are constructed of mass concrete, brick or stone masonry. Massive gravity wall. Counterfort wall. Cantilever gravity wall. What are the assumptions for Coulomb's earth pressure theory? The earth pressure theory proposed by Coulomb is based on the following assumptions. The soil or the retained material is isotropic, homogeneous, and possesses both internal friction and cohesion. The rupture surface is a plane surface. The friction forces are uniformly distributed along the plane rupture surface. The failure used is a rigidly body. There is a wall friction. Failure is a plane strain problem. What is the structural action of the stem, heel, and toe? Stem. The vertical arm or stem is subjected to lateral pressure and acts as a cantilever. The lateral pressure causes maximum bending moment and shear forces at junction of the stem. Heel. The heel is subjected to soil pressure from the bottom acting towards and the downward loads due to self-weight and the earth above the heel. The downward load is more, hence the heel acts like a cantilever is more, hence the heel acts like a cantilever bending downwards. Maximum bending moment and shear force occur at the junction of the heel with stem. Toe. The toe is subjected to upward pressure from the soil and the downward pressure is due to self-weight. Hence the toe is designed as cantilever. Maximum bending moment and shear force occur at the face of the stem. How the development of tension in a base slab is checked. In order to avoid development of tension in the base slab, the resultant of various forces acting on the wall should cut the base in the middle third of the width of the base. Further, the maximum pressure on the base slab should not exceed the allowable soil pressure. What are the factors governing the spacing of counterforts? Spacing of counterforts depends on various factors such as height of retaining wall, cost of steel and concrete, allowable soil pressure and cost of form work. Keeping the spacing of counterforts closer reduces the thickness of vertical slab and the heel slab, and cost of formwork increases. Thus the spacing is the one which makes the design economical. Spacing generally varies from n0.3 to 0.6, where h is the height of the wall. Define the stability of retaining wall structure. Retaining wall as a whole's stability. The following external stability requirements: safety against bearing capacity failure, safety against overturning, safety against sliding. 26. Define factor of safety against overturning. Factor of safety against sliding along the base is defined as the ratio of resisting moment to disturbing moment about the toe. Factor of safety against sliding should not be less than 2.0. What do you mean by the backfill of retaining wall? Loose material like soil, coal, or ore piles retained on the back of a retaining wall is called a backfill. Backfill materials for retaining structure should be designed to minimize the lateral pressure. A good backfill material should satisfy two important requirements via high-long term strength and free drainage. Granular materials make the best types of backfill. What is the function of a shear key? A retaining wall should be safe against overturning, sliding, and bearing capacity failure. The horizontal forces causing sliding forces are the steering resistance offered at the base and the passive resistance before the wall. A main FOS of 1.5 is generally provided. If adequate force is not achieved, a shear key is incorporated in the base. Define active and passive earth pressure. Active earth pressure. It is the pressure that at all times are tending to move or overturn the retaining wall. Passive earth pressure. It is reactionary pressures that will react in the form of a resistance to movement of the wall. What are the effects of active and passive earth pressure? Active earth pressure. It is composed of the earth wedge being retained together with any hydrostatic pressure caused by the presence of groundwater. This pressure can be reduced by the use of subsoil drainage behind the wall, inserting drainage openings called weep holes through the thickness of the stem to enable the water to drain away. Passive earth pressure. It builds up in front of the toe to resist the movement of the wall if it tries to move forward. This pressure can be increased by enlarging the depth of the toe or by forming Arab on the underside of the base. What are the factors to be considered while designing the retaining walls? Overturning doesn't occur. Sliding doesn't occur. The soil on which the wall rests mustn't be overloaded. The materials used in construction are not overstressed. What are the forces or pressure that has to be calculated while designing the retaining walls? Height of water table. Nature and type of soil. Subsoil water movements. Type of wall. Material used in the construction of wall. What do you mean by surcharge angle? The position of the backfill lying above the horizontal plane at the elevation of the top of a wall is called the surcharge, and its inclination to the horizontal is called the surcharge angle SS. What is angle of internal friction, F? The angle of internal friction, which is equal to the ratio of the maximum resistance to sliding on any internal plane to the normal pressure acting on the plane. What are the points to be noted in the design of cantilever retaining wall? The thickness of the stem may be kept the same throughout the height to provide adequate dead load. The base slab may be made about 100 mm thicker than stem. The width of the base slab may be kept about 0.7 to 0.8 times the total height of the wall. It may most probably require a key to be provided to have a safe factor of safety against sliding. What are the loads acting on the heel slab of the counterfort retaining wall? Dead load of the strip. Weight of the earth above the strip. Vertical components of the lateral pressure in the case of the earth surcharged at an angle. What are the structural components of retaining walls? Base, heel, toe, stem and backfill are the structural components of a retaining wall. What are the components of counterfort retaining wall? Upright slab. Its design as a continuous slab spanning horizontally on the counterfort subjected to lateral earth pressure base slab. The width of the base slab may be taken as 0.6 h to 0.7 h, where h equals overall height of the retaining wall. Heel slab. The heel slab should be designed as a continuous horizontal slab with counterfort as the supports. State the advantages of pre-stressed concrete over reinforced concrete. Since the technique of pre-stressing eliminates cracking of concrete under all stage of loading, the entire section of the structures takes part in resisting the external load. In contrast to this, in the reinforced concrete, only portion of concrete above the neutral axis is effective. Since concrete does not cracks, the possibility of steel to rust and concrete to deteriorate is minimized. Absence of cracks results in higher capacity of the structure to bear reversal of stresses, impact, vibration, and shock. In pre-stressed concrete beams, dead loads are practically neutralized. The reactions required are therefore much smaller than required in reinforced concrete. The reduced dead weight of structure results in saving in the cost of foundations. The neutralization of dead weight is of importance in large bridges. The use of curved tendons and the pre-composition of concrete help to resist shear. The quantity of steel required for pre-stressing about 1/3 of that required for reinforced concrete, though the steel for the former should have high tensile strength. Pre-stressed concrete beams have usually low deflection. In pre-stressed concrete, precast blocks and elements can be assumed and used as one unit. This saves in the cost of shuttering and centering for large structures. What are the various loads considered in heel slab of retaining walls? Weight of the backing. Dead load on heel slab. Vertical component of lateral. Upward soil reaction. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.